Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 94 called the binary tree Inorder Traversal. And for this particular challenge, given the root of a binary tree, return the Inorder Traversal of its node values. For example 1 right here, we have the input a equals to root, which contains the value of 1, 0, 2 and 3. Why it's it 1, 0, 2 and 3 is because if we have to visualize this part of node 1, let me make this visible, part of node 1, and we have the value of 0. Let me use the color of lighter blue, and we have 1 right here, this part of 1, and this is the 1, and the next one, which is 0, it is reading from the left using the left property of the 3 node class, since this one is in the form of 3 node. Then it is contain the left property and the right property. By the left property, which means that the left property is pointing to the null. There is no node whatsoever, so null is placed on the second position of the array, and 2, which is the node right property of the node 1 right here, and it is pointing to the 2. And what about the 3? Like the sequence defines, is always starting from the left and then reading to the right property. Since 3 is the left property of the 2, then 3 is considered in the array, and the output is 1, 3 and 2. Why the example is only showing 1, 3 and 2? What is the example behind it? So the example is like, let me reset the drawing. The sample output is reading vertically or column by column, instead of reading from the top branch, which is the main branch of the root branch, and reading from the left and then to the right. And the next one, which initially from the left and then to the right again, and then going down to the subtree, going left and going right again, and reading the property one by one from the left and then to the right property. So let me draw this again. By the meaning of the output right here, which is 1, 3 and 4, is reading from the column by column, which means that it is starting from the left to the right. So let's say I want to have a rough visualization of like this. We have the column of the first column, which is the 1 and 3, and the next column, which is 2, and you have to read it from the top left and then going to the bottom, and then we read to the next column, which is on the 2 right here, since 2 is on the node that is placed on the right side of the column. So the sequence should be 1, 3 and 4, not 4 but 1, 3 and 2 respectively. It's reading from the left to the right, and then since it is reading from the left to the right, since it is a column, then we need to read it from the top to bottom first. So that is the real sequence of the Inorder Traversal of the binary tree. Okay, so for the example number 2 right here, we have several nodes that is interconnected to one another, which is the sequence of, let me enlarge this part, the sequence of 1, 2, 3, 4 and 5, 1, 2, 3, 4, 5 and 8. Null is being counted right here, and this part is null, 4, 5 and 8. If you notice that 4, 5, null and 8, and then null, because null is after the node 4 right here, which is from the left side or the left property of the 4, and the right property of 4 is also null, it is non-existent, and 4 is only the last subtree or the last branch of the binary tree, and then it's still registered as the null property of the root content. And then we have 6, 7 and then 9, and if you notice, we are reading row by row from top to bottom, and then reading from the left to the right side. We are reading from the left to the right and then left to the right again. So that is the sequence of the original binary tree. So how do we use the Inorder Traversal sequence. It is fairly easy by creating a column. Let's say we imagine a column right here. We have this part of a column, and let me have a rough visualization, and we are reading this from the left most of the column, which is 4, and 4 is registered, that is correct, and then 2 starting from the top, remember, and then 6, 2, and then 6, and then 5, which is also on the third column, and then 7, and 7 is because the 7 is starting from the branch, the right branch of the 5, and then 1, which is the root of the binary tree, and then 3, which is the right property of the root after the 1, and then 9, which is starting from this part from the left side of the subtree, and then finally will be 8. So that is the priority of what we are trying to solve this. If you're still confused, let me redraw this again. You might want me to explain this again about the 7, why 7 is placed before 1, and it should be 1 first and then 7 later instead of the other way around. It's because let's say we are traversing from the 1 right here. We are reading this node 1, which is denoted by the blue underline, little blue underline, and then we are traversing over the 2, which is starting from the left. It's always starting from the left because left takes the priority of the Inorder Traversal, and 2 is being read right here, and then reading the subtree again, which is the left property, 4, and then 4 will read the left and right property. Since 4 does not have any left and right property, then 4 is being returned as the answer of the array. So that is the first sequence of the output. And then 2, because 5 takes the priority after the main branch has been read, which is 2 right here, is being registered as the second sequence. And then 5, remember that in order traversal, the priority, which is the left first, denoted by the L, and then the root, which is the R, O, O, and T, and then the last one will be the right property of the root, right property, or the right branch of the root. So that is why the 5 takes the position after the 6. Oh, I'm sorry, it is 6 first, because the 5 is also considered a root of the subtree, and then 6 takes the priority after the 2. So 6 will be placed right here, and 5 is being read, and then 5 takes the priority, which is 4, and then 1, this one, 1, 2, 3, and 4. 5 takes the priority of 4 because root takes the precedence over the right property, and then 7 because 7 is the one that near the main branch of the 5 root, which 5 has been read from the last subtree of the branch. So 7 is being read, and then 7 does not contain any left and right properties, so 7 will be returned as the sequence. So 7 takes the 5, the answer of 5, and we go back up again to the 5, to the 2, and go back to the 1 since we are using the recursive approach, and then we are reading the 1 as the answer of the next sequence, which is on the sequence 6. Remember that the sequence should be left, and then the root of, or the main branch, and then the right property, and the left always takes the precedence over the root first. And we are reading the next property, which is the right property, which is 3. Since 3 is being read and there is no left property, then it is going to be null, and null will not be registered as the 7th sequence. Then 3 will be returned because 3 is placed after the left property. Since left is null, then 7 is placed right here on the sequence after the 1, and then the next one, which is the 8 is being read, and then check if 8 has the left property. Since it is, then 9 is being read again. Check if 9 has the left and right property. If 9 happens to has the left property, then the answer will be placed between the 3 and 9, and will be placed in between them. Since 9 does not contain any left property and right property, then 9 is being registered as the next answer, and the sequence will be the 8th position. And we go back up again to return the 9 as the answer of the array, and then 8, check if 8 has the right property. Since it's not, and 8 is takes the precedence over the right property, then 8 is being registered as the last element, which is the 8 right here. And that way we are returning our answer as the in-order traverse. Okay, so let's solve this out by creating since the function itself expecting a number array instead of the another binary tree or the 3-node data type, then it is fortunate for us to solve this out because it makes the challenge far more easier because of the array sequence instead of the 3-node sequence, because 3-node class has the custom property of value left and right, and that would takes a lot of time to chain between them because we need to understand using the singly linked list or the doubly linked list in our challenge. And then we are using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead. And we have the function of Inorder Traversal that takes only one parameter, which is the root parameter, in a form either of 3-node class or null. It is possible to be null, and we need to have the edge case to check just in case if the number is an empty array. So it is very easy by creating the constant of the answer array that takes only the blank array without the elements, and that way we need to return the answer array. The first thing, we need to iterate over the root array. Since root is being read, then we need to check if the root is null, is equal to null, or using the root by the exclamation mark in front of the variable or parameter. If it is, then we return answer array. And the next one, we need to traverse over the left side of the left property of the current 3-node by using the Inorder Traversal again, Inorder Traversal again of the root left, and to check if it has the answer, then we need to return the answer as it is by creating the after the root.left, we need to declare the answer array.push push the answer of the current root by using the root.value, and that way we are returning the value property of the current root that we are reading of the Inorder Traversal of the current root. Then we are returning this, and answer array will be pushed to new answer array by the root value. The value of this root of the value property will be pushed inside the answer array to the end of the array sequence of the array element, and that if we happen to inserting 4 as the root dot value, and then 4 will be inserted at the end of the array sequence, and instead of the empty array, then we will insert 4 into the array. And then if we happen to adding the 2 into the array, then the 2 will be inserted after the 4, and so on and so forth. So that is the method of the push method, the usage of the push method. And the next one will be the calling another Inorder Traversal, because we are using the recursive function or recursive method, and the root.write takes the sequence after the middle part or the main part of the subtree or the parent part. So there are so many wrong things about this part of the code. Why is it wrong? Is because we are not wrapping this inside the helper function. Why we should insert an helper function to solve this answer Inorder Traversal sequence is because the answer array dot push will push in the root dot value, but then if we happen to use the Inorder Traversal of the root dot left, we will be creating a new instance of the answer array, and the answer array will be pushed into that subtree instead of the main tree. And let's say we are iterating over the Inorder Traversal of the root.left. We're iterating from the 1 and then 2 and then 4. 1 already been read, and then 2 already been read, and 4 already been read, and check if they are both null. Then root already returning the answer array, and the answer array will push the 4 into the array answer of the instance of the 4 right here, instead of the main root or the main branch of the 1 right here. And that will make the array value or the array element separate from the 4. It will be counted as the 4 by itself, and then 2 will be stored by itself right here and not going up to the parent array that calls the recursive approach. So that is the caveat of not using a helper function, and that way it would make the challenge impossible and we will not find the answer at all. So to get around this, we need to declare a helper function. We need to call this function called the function of the traverse, and takes the what should we name this? We can name this as the main branch that takes the property, not takes the property but takes only one parameter in a form of data type of the tree node. And for the next one, we need to insert this into the traverse helper function, and we need to call the traverse function with the root as our parameter, and that way we are calling the root with the traverse, calling the traverse with the root as the parameter, and we're passing the parameter as the main branch right here, and check if the main branch is null, then we need to return the answer array. And for the next one, we are calling the another Inorder Traversal of the root.left and the answer array.push of the, it's not about root.left, but let me rename this using the control D, by using the control D several times, and we check we are selecting 3 of the same variable name, and we can rename this as the main branch. And we are iterating over the left part of the subtree, and then after the left part has been completed, then we need to push the main branch or the main branch of the subtree, and 4 takes the precedence, and then 2, and then the next one will be 6, not 5 but 6, and then 5, and then 7. So that is the sequence. Let me draw this again by using the red color. Okay, the 4 takes the precedence 1, and this part is 2, and then this part 5 being read, and then 6 being registered, and then 5 takes the precedence over the 7 because 7 is the right property of the subtree or the parent of the node, and 7 takes the 5th place, and 1 takes the 6th because the left side of the tree already done counting, already done registered, and already traversed using the recursive approach, and the middle part, which is the parent, is being registered as the next sequence. And then after it has been done, we are moving to the right part. Since 3 does not contain any left property, or it's null of the 3 node, then 3 is being registered as the middle part of the parent and takes the 7th part, and 8 is being read, and then 9 is being registered because 9 does not contain any subtree after that, and 9 is being considered as the child of the 3 node, and then 9 takes the 8th place and the 8 takes the 9th place. And we traverse over the left branch, and we push the middle part of the parent, and then we traverse over the right branch. So that is the sequence of this challenge. Okay, so let's run this out by using the control and apostrophe, and we have the wrong answer 1, 3, and 2. Why is it happening? Let's try to solve this out by using the type, declaring the type of the allowing this helper function to be 3 node, either 3 node or equals to null. Let's run this out again to see if it works, and we still have the wrong answer. Okay, so what about declaring the main branch, check if main branch is strictly equals to null, and then we return the answer array instead. Let's run this code again to see if it works. And we still have the wrong answer, and we only have the output of 1 instead of the 1, 3, and 2. Okay, so I made several mistakes right here. The first thing on why is it only outputting 1 instead of 1, 3, and 2 is because we are returning the answer array directly after we call the traverse root, and that way we are only pushing the main branch dot value instead of processing over the main branch dot left and main branch dot right. And both of the Inorder Traversal recursive call is being ignored. It's not being ignored entirely, but I don't know what happened behind this part. But the only thing is being pushed is just by the answer array dot push of the main branch dot value of the root parameter, which is the only this part, not the 3 and 2 sequentially. So the thing is, we need to use the main branch, check if main branch is equals to null, then we need to return nothing instead of return the answer array directly. And the next one would be, the next mistake is about the using the Inorder Traversal call instead of the calling of the traverse, because we are calling the traverse function. We should be calling traverse function inside of the traverse function instead calling the Inorder Traversal inside of the traverse function. So that is the second mistake that I made. I'm sorry about that. It's supposed to be traverse, and we are traversing over the main branch dot left because main branch is still as the property of left and right from the root, which is the root right here, is being passed, and takes the left property and then register the middle part, and we traverse over the right property, and return should return as it is without using the return of the answer array. It is to check as a main gateway or the main gateway if the current branch to be iterated is already null from the 4 right here. If they are both null, then we return the 4 instead, and the traverse of the left branch will be stopped, and the answer array will be triggered, and 4 is being registered. And next is by using the traverse main branch dot right, so that is the real sequence. And since right is null, then we end the function after we go back from the 4 of the recursive call. Then after the traverse of the main branch dot right, we are not registering the answer array dot push because answer array dot push is placed before the traverse of the main branch dot right or the node right. And then we go up and returning our answer of 4 of the answer array, and we are returning to the 2 right here. 2 is being registered as the answer because it is the middle part and the left part already done. Since it is 4 is the left part, then 2 is being registered, and then the answer array dot push is pushing the 2 as the answer right here as the part of the answer. And then we are traversing over the main branch dot right, which is 5 right here, and 5 will traverse over the 6 and starting from the left again, and we are iterating over the next node of the left node and right node of the 6. Since left node of the 6 is null, main branch left null, then it is being returned. Then the next part, which is the middle part, which the parent answer array dot push, and 6 is being registered as the answer right here of the Inorder traverse sequence. And then after that, see, the traverse function will be called again, called itself, and checking main branch dot right, and that is taking the parameter as the parameter of the traverse function of the recursive call. And since the right is null, then it is being triggered, this part is being triggered, this part of the traverse code. Then 6 is returned, and 6 is done from the operation, and 5 is being registered because 5 already traverse over the left, and the left traversal is, I'm sorry, there was a guess. Okay, so the next one is where do we left off? Okay, so the traverse of the main branch dot left, since left is already triggered, or already the operation has already been completed of the traverse call of the left branch, then the answer array is being pushed inside the answer array of the 5 inserted into the answer array, and then 7 is being triggered using the traverse of the main branch dot write. And so that is the sequence that we are trying to solve right here. So that is the sequence. Name of the sequence is the Inorder Traversal. Okay, so this should be enough, and let's run this out, see if it works. Make sure everything is already correct, and there it is. We have the accepted answer of the 0 millisecond. Let's submit the code. Okay, since we are using the recursive call, then the memory complexity takes only the 8th percentile of the overall performance of every challenger. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.